Hello, everybody, and welcome to this webinar entitled An Introduction to Java on AWS. My name is Lee Packham. I'm a senior developer advocate working within developer tooling. And with me, I'm very fortunate to have Ben Maisels, who is a senior software development engineer. Today, we're going to cover a few different areas around Java on AWS. So we're going to take a look at the JVM ecosystem, because Java is obviously just one part of a larger ecosystem. And we'll look at the different areas in which you can use AWS from the JVM. We'll dive a little deeper into Amazon Corretto and the Amazon Corretto crypto provider and how they're useful to customers. Ben will take a deep look into the new version of the AWS Java SDK. And we'll then spend some time looking at the AWS Cloud Development Kit, or CDK. It allows you to build out your infrastructure using Java or another language that you're familiar with, and why that is a good thing for deploying your code. By the way, a little bit of background. Obviously, I'm Lee Packham. I've been in the industry for just over 20 years across both systems architecture and DevOps. I spent a lot of time deploying different languages, but also writing in different languages. I've been very fortunate to be able to spend time working on things like Go and Scala, and used a lot of C when I worked on embedded systems, and more recently been playing around in Rust. I actually am a contributor to a number of different projects, including the CDK, which is why I have this role that I have now. I've been at Amazon for a couple of years, working primarily with customers in the first 2 years, but now spending most of my time getting the right tooling in front of customers and getting feedback around the different services that we provide. I've provided my Twitter handle here and my email address, and that's on purpose. It's provided again at the end. Please feel free to get in touch if you want to. And Ben?
Hi, my name's Ben Maisels. I'm a senior software development engineer at Amazon Web Services. I joined Amazon back in 2002, and I've been working on a broad number of services and products at Amazon since then, both for AWS and also outside of AWS. Right now, I'm on the AWS Java SDK team, which is what I'm here to talk to you more about today. And also, I've been contributing to the AWS CDK, which we're also going to talk about, specifically the Java interface.
So let's spend some time having a look at the different areas that the JVM ecosystem and AWS work closely together. There's not just the AWS services in which you can deploy your Java code. So say you're working on like a Spring Boot application, you can make different choices of how you want to run that. You can use things like AWS Elastic Beanstalk, or you can run it directly on EC2 instances, or make use of something like Amazon ECS or Amazon EKS to run it. Then you've also got different services that you may connect to and use. Very commonly, things like S3 for retrieving data that you might be using for data processing, or workflow with things like step functions, or using DynamoDB, a NoSQL database giving you sub-millisecond access to your data, making use of the Java APIs to interact with your data there. More than that, though, we're adding things to this all the time. And a good example of this is Amazon Corretto, which is Amazon-supported implementation of the OpenJDK, which we'll go into a bit further in a minute. Things like serverless deployment, making use of integrated development environments or IDEs that you're already using, such as IntelliJ IDEA. But as customers started doing more with serverless and Kinesis and DynamoDB, a newer version of the SDK was required for that. And that's where AWS SDK for Java v2 comes in, which Ben will go through in depth a bit later on. The AWS SDK for Java v2 actually brings us faster startup times to Lambda. Customers want the faster startup time as they use Lambda behind things like the API gateway service, where it's really important that the Lambda is responding in a timely fashion. And the new version of the SDK for Java gives you that. And then more than that, being able to use a familiar language to deploy your infrastructure. So whether that be configuring VPCs or how you set up networking within AWS, or right down to how you configure things like code build or code deploy, you can make use of something called the Cloud Development Kit, which we'll go into why that exists and what that really provides you a bit later on. The newer SDK also gives you full duplex streaming for Amazon Kinesis, which is really important because it means that you get lower latency access to those streams that have more data flowing through them. Whereas before you would have to use an HTTP1 API, which was more of a request and response type behavior. So Amazon Corretto is a new fork of OpenJDK. It's our distribution of the OpenJDK, and we actually run it internally on thousands of production services. In fact, I was surprised by this. I recently visited some teams that have migrated onto it, and they tell me that it just dropped in and they replaced the existing OpenJDK with Corretto, and they carried on running. It doesn't just run on Linux. It also will run on Windows and Mac OS, as well as environments like Docker. In fact, I've heard of one customer who is using the Amazon Corretto as their main Windows distribution of Java on the desktop. So it can be used in those kinds of environments, not just on the server. There's no cost attached to it. It's distributed under an open source license. There's no charge for use or distribution of it. And with this comes no cost LTS or no cost long-term support. So we're always patching and doing performance improvements to it. And we do seek to get these patches upstream as well. Both Corretto 8 and 11 are generally available. So that's compatible with OpenJDK 8 and OpenJDK 11 respectively. It's fully open source, and you can go and have a look at GitHub, github.com/Corretto to see the project and be able to contribute or raise issues with us directly if there's something that's not working for you with it. As part of the Corretto project, it turned out one of the things that customers work with Java a lot, they're doing a lot of encryption or cryptography. And although you can do that with Java itself, there are ways to make it more performant, such as using a replacement cryptographic provider. And that is what the Amazon Corretto crypto provider does. It's a collection of high-performance cryptographic implementations, and they're exposed by the same standard as other cryptographic providers, which means it can be used as a drop-in replacement for many different Java applications. To give you an example of this, there is a customer that has actually used it as a drop-in replacement on Cassandra, so running a Cassandra database, and they're able to benefit from lower memory and CPU usage as a result. The algorithms it supports are primarily backed by OpenSSL implementations, and it's compatible with both OpenJDK 8 and 11, as well as Corretto, which we just mentioned, and Oracle JDK 8 as well. But only on Linux, only on 64-bit Linux at this time. It is open source on GitHub, so again, you can go and take a look at that, and you can see how that works and see if it works for you. And I highly encourage that you check this out, because it might be a great quick win for being able to get more performance out of your existing Java applications. So with the JDK covered, let's take a look at another area where customers are interacting with the JVM ecosystem a lot. And that would be their IDEs. Now, developers work within a number of different things. And actually, by far, from at least my personal experience, what I've seen, a lot of developers, or most Java developers, make use of IntelliJ IDEA, which is provided by Jetbrains. There's also PyCharm for Python, very popular for people working on machine learning workloads and things like that, but also building web applications in Python. But JetBrains actually has a much broader ecosystem. It actually has a number of different IDEs for different areas, whether that be WebStorm for JavaScript, C-Line for C, C++, so those embedded IoT applications, RubyMine for Ruby and Ruby on Rails, Rider for .NET Core, and AppCode for working on iOS or Mac applications, as well as Golang for working on Go applications. It's really important to us that we meet developers where they are. Developers are already using these IDEs to work on their applications. It makes a lot of sense that we should be working within those IDEs as well to give customers the best experience working with AWS. And that is where the AWS Toolkit comes in. The AWS Toolkit is a plugin currently for IntelliJ IDEA and PyCharm. It makes it a lot easier to develop on AWS. It is open source, so you can go and have a look at the source code on GitHub. The initial focus is on serverless applications, so things like using AWS Lambda. It actually lets you debug those Lambda functions locally, so you can actually step through your code locally. It makes use of the SAM CLI to do that. So SAM CLI and Docker are used to achieve that locally. It has basic resource credential management that's improving all the time. And the idea is to grow support across AWS. And the URL here is where you can go and find out more information about the AWS Toolkit. I'd now like to hand over to Ben, who's going to talk about the AWS SDK for Java.
Thanks, Lee. So before I dive into the V2 of the AWS SDK for Java, I really want to just take a high-level look at what the AWS SDK for Java actually is and why you might be using it or should be using it. So first of all, what is the AWS SDK for Java? If you're running a service somewhere on your JVM, whether that's running on your own infrastructure or running perhaps on EC2 or Lambda, and that service needs to talk to different AWS services, then you can use the AWS SDK for Java to essentially handle the communication between your application and those services. So let's take a deeper look at what specifically the SDK does. We handle credentials for you, whether that's in a profile or whether you handle them directly or whether it gets them from EC2. We handle endpoint construction. So no matter which service you're using or which region you're using it in, the SDK will be able to create the correct endpoint for you. We handle the different service protocols that the AWS services speak. We will sign requests for you using the authentication that you've provided from your credentials. We handle the transport layer, HTTP, and now more recently, HTTP2. We handle streaming input and output. Also, we do timeouts and retries. So essentially, if your application needs to configure custom policies around how to retry requests, we give you the ability to do that. But out the box, we'll give you a sane set of behavior for that. We will also handle errors and exceptions that come back from the service and model those in a way that your application can easily understand. And we'll also orchestrate asynchronous communication. So if you wish to write a service that does not block and uses the asynchronous operations in the SDK, we'll take care of all the complexity behind that. So let me talk a little bit more about V2 of the SDK for Java. We launched this in November 2018. One of the key features of it is that we leverage Java 8 language features. So the V1 of the Java SDK was actually pinned to JDK 6 until very recently, where we were actually able to repin it to JDK 7, but still, we wanted to take advantage of some of the more modern features that the language level 8 gives us. Another one of the key design decisions that went into this was around AWS Lambda. So one thing we have definitely heard our customers tell us is that there is some pain around the cold start time of Java applications running in Lambda. And we know that some of that pain comes from the AWS SDK. So when we designed V2, we wanted to make sure we were doing everything we could to reduce that cold start time. Two of the ways that we did that was we reduced the dependency footprint. So overall, it's a smaller artifact. We also looked into how we could make the SDK faster in terms of initialization itself. So we have less use of libraries that have expensive initialization. And we even provided an option for customers to use a different implementation of the HTTP client that will actually initialize faster and is ideal for Lambda. And I'll talk a little bit more about that in a bit. We also wanted true non-blocking asynchronous support. We do that through a third-party library called Netty. We also support HTTP2 for streaming for some of the services. Right now, that is Kinesis and Transcribe. We also allow the HTTP client to be plugged out. So if you have an implementation of the HTTP client that you would like to use, you're welcome to do that with this SDK. And we provide all of this as open source on GitHub. So I just want to take a look now at the actual code itself, so you can really visualize the difference of what I'm talking about here. So here's a simple Java method that you might want to do, for instance, like to get keys for your bucket. It seems like a fairly routine thing. This is the code that you would need to write to do that properly using the V1 SDK. As you can see, there's quite a lot of code there that you might not expect to be there. And most of that code is actually handling the possibility that you might get back an incomplete list of results. The SDK does not handle that for you, so you need to write for loops and while loops to essentially continue to iterate, making calls to S3 saying, do you have any more results, until you get the thing you need. So this was one of the many pain points that we heard and that we wanted to address in V2. So for any operation in V2 that is paginated, we will provide a version of that operation called a paginator, as you can see there, list objects v2 paginator, that will handle that iteration for you. So all you have to then do is say, give me all the results from that operation, and then do whatever you want with them. In this case, we're just putting them all together into one big list. So as you can see, the code there, we feel is far more fluent and readable. And that's just one example of how we tried in V2 to give a better Java 8 experience. So if you want to actually get going with this and use it, how do you do that? The easiest way is to add a dependency into your Maven project. There's an example there. So the SDK V2 is modularized per service. So in this particular example, this shows how to bring S3 into your service. But if you're using other AWS services, you simply substitute that line there with the name of your service. Alternatively, you can get the source code in its complete form from GitHub and compile that directly into your project. So now, as a SDK developer myself, I want to give you a few tips of how you might get a few more milliseconds out of your cold start time, because that's something we certainly care a lot about at Amazon, and something that we hear from our customers is very important to them. So my first tip is that you should not use the default HTTP client that comes with the V2 SDK. We also provide something called a URL connection HTTP client that will use Java's implementation of the HTTP client directly. There are pros and cons with this. So the real advantage of using this is going to be low initialization time. The disadvantage of it is that it does not have the complex connection pool handling and sharing and caching that the Apache HTTP client does. However, if you are running a Lambda application that perhaps performs only one or two operations, and you are not having to handle a large number of concurrent operations in large volume, the URL connection HTTP client would be a better choice for you. The second piece of advice I would give is to make sure you're tuning your timeouts and retry policies. There's really no one-size-fits-all solution for this. Every service has a different way of handling timeouts and retries and what's ideal for them. My advice would be to think about it, understand that this is something you can change, and that the default settings are probably not going to be good. So once you start from that assumption, then baseline your service, look at your metrics, see what performance you typically expect to get on a good day out of your service. And from that, you can create timeouts and retry policies that will give you the most responsive behavior if there's any kind of transient outage or something of that effect. Another tip is to explicitly specify the region when you initialize the SDK. This will shave a few milliseconds, because if you do not do this, the SDK has to try and figure out which region it's in, and that can take a little bit of time. Another tip is to explicitly specify the credentials provider when you're initializing the SDK. By default, the SDK will search through a known list of credential providers until it finds credentials that it can actually use. This can take time, especially if the one that it ends up using is far down that list. So you can speed up this process by explicitly initializing it with a credentials provider. Another tip is if you're running the SDK in AWS Lambda, make sure that you're reusing initialized SDK clients. You can lose a lot of time if you're reinitializing the SDK client unnecessarily. Another tip is to avoid using the V1 SDK side by side with the V2 SDK. Now, we actually state in our documentation that this is possible to do because they're in different namespaces. This was something we intended to do to make it easier for people to migrate to V2. However, if you initialize both a V1 SDK and a V2 SDK in your application, you're going to be paying double the initialization cost. And there's no way around that other than to not share. So if you are migrating from V1 to V2, I strongly recommend that for each individual application in its runtime that you migrate everything to V2. I've also provided a link here for more best practices. Feel free to check that out. So now I'm going to switch gears a little bit and talk about the DynamoDB enhanced client. This is what we call a high-level library, which is something that we write by hand to bridge a usability gap between what we perceive as the operations and the API that the service itself provides and what developers are actually trying to do with the service. And a great example of that is DynamoDB. So DynamoDB is a NoSQL database. It's widely used both inside and outside of Amazon. But one of the problems with it is that databases don't translate very well into RPC-style interfaces. That's why we have things like JDBC. But unfortunately, DynamoDB doesn't look anything like an RDBMS, so JDBC wouldn't be an appropriate interface for it. So instead, we decided that we would invent something to help customers have a better experience with DynamoDB. There is already something in V1 that helps customers do this, and that is what's known as the DynamoDB mapper. We also have the DynamoDB document API in V1, but because V2 is a new product, we took the opportunity to really rethink this rather than just, let's port this straight over. So what we came up with is this idea of the DynamoDB enhanced client. It's essentially a layer that sits on top of the low-level DynamoDB client, and it will provide a fluent and concise execution style for what is sometimes some complex DynamoDB operations like query and scan, but it will cover all operations. It provides type-safe Java object mapping and attribute conversion, so you don't have to worry about how you're turning your string into an attribute value or reading an instant out of an attribute value. We will handle all that for you, and the compiler will detect if you've made an error, like you're trying to read an attribute that can't support the value you're trying to read it as. We also provided multiple implementations because we understand that people want to use this thing in different ways and for different reasons, and there is no one-size-fits-all experience. So for people that want the easiest solution where they can just dive straight in and start using DynamoDB, we provide a schemaless document mapping interface. This is really similar to the document API in the V1 SDK. We also provide an introspective bean mapping implementation, and this is most similar to the DynamoDB mapper in V1 and will be very familiar to people that have experience using the DynamoDB mapper in V1. We also provide a direct static declarative mapping implementation, and this is the fastest implementation for customers that are running in Lambda and want to reduce their latency using DynamoDB. So now I want to give you an overlay of how this thing is put together and how you would actually use it. So starting with a table schema, that's the first ingredient for the recipe of the DynamoDB enhanced client. This is an object that knows how to map a record to a Java object and back again. It also contains structural table metadata, such as the names of your indices. These are the three implementations that we provide for it that I talked about in the previous slide. The next ingredient you're going to need is a regular DynamoDB client from the V2 SDK. And then putting those together, from that you create an enhanced client. From the enhanced client, at that point, you can already start to perform database level operations such as batch get item, transact write items. These are operations that work across multiple tables, so they're not bound to a specific table. When you want to work with a specific table, you will create a DynamoDB table object from that, and that will give you table operations such as get item, put item. And then if you wish to work on a specific index, such as a secondary index, such as a global secondary index or a local secondary index, you can create a DynamoDB index from your DynamoDB table and then perform index level operations, which currently is only query and scan. So let me talk a little bit more about those different table schema implementations. The document table schema does not require you to declare a schema. It will perform lazy conversion of attributes on demand. So you will read your entire record into a buffer. And then once you actually wish to use a specific attribute, you will query that document for that attribute. And that's when the conversion will be applied. We believe it's the simplest interface, which makes it ideal for experimentation and proof of concept. We then have the bean table schema. This will read table metadata and the table schema directly from your bean class, so you do not have to provide any additional configuration. Once it's initialized, it will be static, so it will not continue to introspect your bean and you will not be paying the cost for that, so it is quite fast. It will also be familiar to users of the DynamoDB mapper in the V1 SDK, because the syntax of the annotations is very similar. We believe that this was ideal for migration from V1 due to its similarity with the DynamoDB mapper or any applications that already heavily leverage beans. Finally, we have the static table schema. In this implementation of the table schema, you're required to declare all of the attributes up front at initialization time. This does mean that you can do it in a static block. It also doesn't require your map classes to follow any bean standard, and you are not having to pay the cost for class introspection. It is a little bit more verbose than other implementations, which you'll see when I show you the code samples, but it is the fastest of the three implementations, which we believe makes it ideal for AWS Lambda functions. So let's first have a look at what the annotated bean would look like that you could use for the bean implementation of the table schema. So this is a fictional class called customer, has an ID and name created on. And you can see there that we've annotated two different things. First of all, we've annotated the class to say that it is a DynamoDB bean. This is really for readability, so that when someone looks at your code, they can see how this class is being used. And we've also indicated where the DynamoDB partition key is, so that that structural information can be used by the table schema. Here's a side-by-side comparison just to illustrate the differences of those three different schemas. You can see the document one actually uses a document type because it does not know that you're reading a customer record. So, whereas the other two, you are typed specifically to your customer record. As you can see, the static table schema is a lot more verbose than the bean table schema, but it does not require your class to be inspected. And there are just a few more steps to actually use the enhanced client. So here, the first thing you're doing is initializing the client. We take a regular SDK DynamoDB client, we put it into a DynamoDB enhanced client. We then create the DynamoDB table from it. At this point, this is where we're associating the table name with the schema. And then here's an example of an actual operation and the fluent style that we provide. So if you were writing this operation as a regular low-level SDK operation, this would look a lot more complex than that. So this is currently a preview. We will be releasing it soon. However, we would love to get your feedback. So here is the Maven dependency details if you want to give it a go and let us know what you think. So just wrapping up, the SDK v2 launched in November 2018. I've provided some links there for you to have a look and get going with it if you like. And we also have launched the Kinesis client library version 2.0 that accompanies it. And there's another link for that soon. And we have a roadmap with several different high-level libraries. The enhanced DynamoDB client that I talked about today. We're going to provide a library for S3, managing multi-part uploads and downloads, IAM policy generation, and API gateway client generation, and anything more that you let us know that you would like. And of course, we always welcome your contributions. Thank you.
So now let's take a look at the AWS Cloud Development Kit, or AWS CDK, which allows you to define your infrastructure using Java. But it's really important that before we do that, let's take a look at why the CDK exists and how customers get to the point that they want to use a higher level language to build out their infrastructure. And if we think about very quickly about how customers start using AWS initially, it's using the console, doing it manually. Whether that be creating instances, creating SQS queues, you can do that via the console. There's a number of different wizard type environments you can go through to build out these things. And it's really easy to get started. The problem with that is that it's not reproducible. If I want to go and create a second instance, I've got to go and hit launch instance again. And I've got to go through that process again. And the other problem that comes with that is, say I'm configuring these instances, say I'm making use of user data. And one customer I worked with a couple of years ago was actually doing this, where they would actually launch an instance. And part of their runbook would be, go here, launch an instance, put in this user data, edit the user data to say something else, depending on what you're trying to deploy. That's quite error prone. That's open to a lot of human error, which means that then you've got to destroy it and start again. And that's very time consuming. It's very difficult to go and do things like create test environments and things like that. And this leads customers onto a journey where they can go a little bit higher level, where it's like, okay, well, let's AWS is built on APIs, right? So I can just go ahead and I can make use of that to do what I want to do. I can script it. This example is in Ruby, but I could easily do it in Python or Java, or even in Bash script. And although the example here shows a very simple create instance, what do I do if this API call fails? Ultimately, I'm going over a network. What happens if that API call doesn't work out as intended? What if I've hit my EC2 instance limit, for example? What do I do when I want to make updates? That an API call called create instance doesn't mean I can alter the instance. It just means I've created it. So how do I make an alteration to it? How do I know when I need to do that? How do I know when the resource is ready? How do I know that when I've created my instance, I can then go ahead and add it to a load balancer, for example? Which leads on to how can I do rollbacks? This error handling around working with a scripted environment is quite hard. And this is where you might end up moving towards something like a resource provisioning engine. And a resource provisioning engine such as AWS CloudFormation or partner solutions such as HashiCorp's Terraform takes a desired state configuration. So you typically define this as a JSON YAML, or in the case of Terraform, using the HashiCorp configuration language. And you define what you want the end state of your infrastructure to look like. So you say that I want it to look like it has a VPC and that it has this number of subnets within it. And then the job of the resource provisioning engine is to go ahead and make that happen. Now, this is great because it's really easy to automate. The resource provisioning engine is taking care of that for you. You just have to define what you want the end state to look like. It deals with updates and so on to make that happen for you. This means it's also reproducible. So you can tear it down and put it back again. In fact, that's exactly what I used to do in one of my roles just before I worked at Amazon, where I was working with Terraform and did exactly that. I would just tear down the entire thing and redeploy it. The downside of these, though, is it works using a configuration syntax. It's very limiting working in something like YAML or JSON or HCL to do dynamic configuration. A good example of this is things like VPC peering, which requires you to do things like set the peering up, but then define the route tables between different subnets. And that's you can do it within these types of languages, but there's a lot of heavy lifting that goes with that. You have to manually define these things. There's no abstraction. There's a lot of detail. If I want to define a VPC which would meet the kind of standards in organizations I'd worked at before, it would take hundreds of lines of these types of configuration languages to achieve. But it would be reliable and it would be reproducible, easy to automate. But we're developers, right? So we can surely make this better. I can surely take JSON and YAML and make it better. Well, yeah, you can. You can make use of a document object model type approach, which uses something like open source projects like Troposphere, GoFormation, and so on, which allow you to use real code to generate that JSON or YAML for CloudFormation. This is awesome. I can make use of real code, and I'm still doing that desired state. And that desired state, as we said, is like really reliable and a great way of defining our infrastructure. But abstraction does not come built in. I still have a lot of detail. A good example of this, a colleague of mine, a solutions architect based out in Dubai, actually spent some time doing this and worked out it's about 218 lines of Python to deploy a VPC in Troposphere. So how can we make this easier? How can we make it so that we're thinking about deploying infrastructure the same way we think about structuring our applications? We make use of object-oriented languages such as Java. Why can't we take that approach and use it with our infrastructure? And this idea is what led to the AWS Cloud Development Kit, or CDK, which takes a component-style approach to defining your infrastructure. That is, you have an application or a CDK application, and within there, you define stacks. So stacks are stacks of constructs. And within those constructs, you may have more constructs. So you can take a fully object-oriented approach to it. But the end result is you go to components that are representing the actual AWS services you're interacting with. This is then taken and compiled into an AWS CloudFormation template, which can then be deployed using the resource engine that AWS CloudFormation provides. The Cloud Development Kit supports a multitude of languages, including Java, but you can also make use of TypeScript or JavaScript, C#, and Python on top of Java. In fact, if you write your own constructs and you wish to distribute them as open source items, if you write them in TypeScript, then users of your project can then use that in Java or C#. But you can write those reusable components in Java itself. So let's look at a really simple example of a stack. Let's look at a queue and a topic. And let's subscribe the topic to the queue. So if we were to write this out in Java, you can see that I'm able to use the builder pattern to build out my queue and my topic. And then to do the subscription, I can just call add subscription on the topic object. I haven't had to define the IAM rules that go with this, but let's have a look at what this compiles to, because I think then that would give you a deeper idea of where this then goes. So here, as you can see, I've defined a queue and a topic, and I've subscribed one to the other. To do this, I have to do things like set up a queue policy. Well, that can be done. So you get a template that's generated by the CDK. And you can see here what I was talking about. You have a topic, which is the last item that was listed there. You also have a queue, which was the first item. You can see that, that the topic is able to send messages to the queue, because that's what the queue policy is then provided to do. And then the subscription is then set up as well. So with that in place, let's have a look at quickly, like, how are we getting this multi-language approach? It looked like we were able to do the builder pattern, but when we normally talk about things that are generated to work on multiple languages, how can we be sure that when a new version of the CDK is released, that it's always up to date in all the languages provided? Well, behind the scenes, there's an open source project called JSII. So the CDK itself is written in TypeScript/JavaScript. So TypeScript compiles down to JavaScript. JSII then generates the APIs for the different supported languages. And it makes sure that those generated components are working in a way that's natural to the language that's being provided. So in Java, you see the builder pattern, but in Python, it uses the class init pattern. That allows you to go ahead and use default arguments on the constructor, which is common within Python. Now, to make use of the CDK, you still need to install Node.js, and then you can go ahead and you can just install it. To install it is really straightforward and works on Windows, Linux, and Mac. And you just run npm install -g, which means global, AWS CDK, and that will install the latest version. You then just have to make a directory to create a directory to work on your new project, change directory to that directory, and run the CDK init command. The CDK command also provides for deployment. So CDK deploy will allow you to deploy, and CDK synth will allow you to go ahead and have a look at how you can see what the template that's being produced. Highly encourage you to check it out. You can find more details on GitHub. So you can go to github.com/AWS/AWS-CDK, or you can go to the aws.amazon.com website to read the documentation there. And with that, I want to thank you for taking the time out of your day to learn about Java on AWS. I've included both mine and Ben's details here for you to get in touch. And thank you for taking the time. Bye-bye.